Okay, so we're going to finish talking about circles by looking at secants, tangents, and angle measures. So we've previously looked at secants and tangents, secants and chords. So what we want to do is we want to introduce the concept of a secant. So first off, let's remember that a tangent is if you have a circle and we draw a line and that line intersects the circle only at one point, exactly one point. Just kind of hits the circle and just continues on in a straight line. That is a tangent. A chord is where we take a line from a circle and we connect it to another edge of the circle. Now, bear in mind, we can't put it right through the center of the circle because if we do that, then it is the diameter. So if I do this, that is the chord. So what is a secant? Well, like I said, if we connect 2 points of a circle, that is a secant, that's a chord. And if I just extend this outwards, making that a line, that is a secant. So a secant is nothing more than a chord that just continues on, whereas the chord stops within the circle. So let's look at some theorems involving secants. So if I have two secants that intersect in the interior of a circle, so not necessarily the center, so it looks like the center's about here for this circle, right? So anywhere in the circle, then the measure of an angle formed is 1/2 the sum, the measure of the arcs. So for example, this is angle 1. It's right here, this is angle 1. And so notice that is equal to 1/2 of AC, which is this angle, plus BD. Angle 2 is 1/2 of AD plus BC. So we can add those two arcs together and get angle 2. We can add these two arcs together, divide by 2, and get angle 1. So here are some examples. And so we can see that the angle here, 2x plus 81, that's the angle, and that's going to be equal to 1/2 the sum of the intercepted arcs, which is going to be 72 and 90. So 72 plus 90. So we get 2x plus 81 is equal to 1/2 of, this is going to be 162. So we get 2x plus 81 is equal to 81. Well, actually, we can subtract 81 from both sides, so we just get 2x equals 0, so x equals 0. Over here for number 2, we can say that 6 plus 9x is equal to 1/2 of 5x plus 155. Now here, because we have this other x, these aren't even, it's probably going to be easier just to multiply both sides by 2. So if I do that, I get 12 plus 18x is equal to 5x plus 155. I can combine my like terms, so I get 13x is equal to 143. And then this way, 143 divided by 13 is just 11, so x is equal to 11. For problem 3, we have that 102 is equal to 1/2 of 90 plus 19x. So I'm going to multiply both sides by 2 again, so I get 204 is equal to 90 plus 19x. Switching things around and subtracting, I get 19x is equal to 204 minus 90, which is just 114. And so if we divide that by 19, we're going to get that x is equal to 6. And finally, this is not a great picture. This is the angle there, so that's 11x plus 1, which is equal to 1/2 of 150 plus 50. Those are nice numbers because 150 plus 50 is just 200, and 1/2 of 200 is 100. So 11x is going to be equal to 99, so x is equal to 9. All right, so that's simple, but now we have the issue where if we have a secant and a tangent intersect, then at the point of tangency, so where they intersect, or I'm sorry, where the line is tangent to the circle, not necessarily where they intersect, the measure of each angle formed is 1/2 the measure of the intercepted arc. Actually, the point of tangency is the intersection point, so look at that. All right, so let's go through this. What does that mean? The measure of each angle, so this angle here, is 1/2 the measure of the intercepted arc. Well, there's the intercepted arc. So the measure of the angle, 3x minus 2, is equal to 1/2 of 100. So we get 13x minus 2 is equal to 50. So 13x is equal to 52. And then 52 divided by 13 is 4. So x is equal to 4. Now, this one's a little bit trickier because we don't have the measure of the intercepted arc. But remember that the arcs add up to 360 degrees. So this is just 360 minus the other arc, which is 32x plus 14. I put that in parentheses because this distributes, so I get 360 minus 32x minus 14. So this arc is going to be 360 minus 14, which is 346 minus 32x. So that means that the intercepted arc, 5x plus 5, is equal to 1/2 of 346 minus 32x. So I could probably distribute that in, or I'll do 10x plus 10 is equal to 346 minus 32x. So I get 42x is equal to 336. So 336 divided by 42 gives me x is equal to 8. Over here, nice another simple one. So this is going to be the angle. The angle, which is 76, is equal to 1/2 of 38x. So that means that 76 is going to be equal to 19x. So 76 divided by 19 gives me that x is equal to 4. All right, now over here, I have that the angle 55 is equal to 1/2 of 2 plus 124x. So I get that 55 is equal to 1 plus 100, 1/2 of 124 is 62. And so I can say 54 is equal to 62x. So x is equal to 54 divided by 62, which is 27 over 31. I got a weird answer, so let me just go back and make sure this is all looking good. So the angle 55 is equal to 1/2. Oh, nope, that is completely wrong. I am sorry. See what I was doing, I was thinking about something else in my head, and I made a mistake. This is exactly the same as number 2. This is the intercepted arc. So this is 360 minus 2 plus 124x. Let me make that a little bit nicer. So this right here, the intercepted arc is 360 minus 2 plus 124x. So that is going to be 360 minus 2 minus 124x. So we get 358 minus 124x. So that means that 55 is equal to 1/2 of 358 minus 124x. So then 55 times 2 is going to be equal to 110, which is equal to 358 minus 124x. So 110 minus 358 is going to be equal to negative 248, which is equal to negative 124x. Divide, and we get x is equal to 2. I'm pretty sure. So that looks a little bit better than the previous one. So don't get confused like I just did. Make sure you have the intercepted arc. You don't just set the equation equal to anything that's there. Okay, so then we have these three situations now where we could have an intersection point outside of a circle. We have three scenarios. Either the two lines are two secants, one of them's a secant and one of them's a tangent, or they are two tangents. In the case where you have two secant lines, the angle formed by the two secants is 1/2 the difference of the intercepted arcs. So the intercepted arcs would be DE minus BC. Or if you have a secant intercepting with a tangent, it's going to be 1/2 of DC minus BC. So notice that with two secants or a secant and a tangent, it's the same difference, right? You're subtracting the far arc minus the close arc. But when we have two tangents, well, if we just subtracted this arc minus this arc, it would be 0. So we're going to have this arc, which is BDC, minus BC, and it's 1/2 of that. So it's the same type of approach for all three, but it looks a little bit different. So looking at the two formulas above, here for number 1, we can see we have two secants. So we're going to have the measure of the angle, so 2x plus 10 is equal to 1/2 the difference of the arcs. So this is 100 minus 4x, which is the near arc. And I can actually distribute that 1/2 in. So I get 2x plus 10 equals 50 minus 2x. 2x plus 10 is equal to 1/2 of... All right, so then I'm going to add 2x to both sides. So I get 4x is equal to 40. So that means that x is equal to 10. For the next problem, I have a secant and a tangent, so it's the same sort of a difference. So that angle, 31x plus 2, is going to be equal to 1/2 of 96x plus 3, so that far arc, minus 67. So cleaning this up, I get 31x. Actually, I'm going to multiply both sides by 2. So I get 62x plus 4 is equal to 96x minus 64. And so I can combine my like terms. So I get 96 minus 62, which is 34. So I get 34x is equal to negative 68. So x in this case is equal to, oops, this is a negative 34, so that means that x is equal to a positive 2. And then we have number 3. So number 3, we have two tangents. So if this is 127, notice the other one is not labeled. But that's just going to be 360 minus 127. And 360 minus 127 is 233. So we're going to have 53x is equal to 1/2 of 233 minus 127. So we get 53x is equal to 1/2 of 233 minus 127, which is 106. Well, half of 106 is 53, so we get 53x is equal to 53, so x is equal to 1. So same sort of approach, same sort of process for all three of these problems. And that's it. So make sure you know how to do these formulas. Realize when you have a secant, a tangent, two tangents, and also where the intersection point is, whether it's on the circle, or it's outside of the circle, or it's inside of the circle. So there are three different formulas there you need to be focused on, but that will just come with lots of practice. So good luck.